In this recording, I will talk about shadowing. First, I will explain what is shadowing in different contexts, including in if statement, in loops, in functions, etc. Next, I will talk about shadowing in classes member functions, and I will talk about shadowing in inheritance. And finally, I will explain the difference between shadowing and overriding, which often remains confusing to many people. What is shadowing? Shadowing is a process whereby a variable defined in a narrower scope, like in this case, this is a narrower scope, and everything that is outside this curly braces or outside the main function is a broader scope from the perspective of this scope of the main function. So, any variable that is defined in this narrower scope hides or gets used over a variable defined with the same name defined in a broader scope or outer scope, right. For example, if I have a variable called x, x defined in a global scope and initialized to value 5, and if I have another variable, it could be of same type or different type. Let me have double type x equals to 3.4, which is defined 3.5 defined in the main function, which is narrow scope. Now this variable actually from the point of its definition until the scope of this variable, it actually hides or it shadows the another variable x, variable x defined in the broader scope. So at this point, if I try to use this variable, it will be the value the variable with 3.5 that will actually get displayed. But if I define before, if I try to use variable before its definition, it will be the the global variable that is going to be accessed. So this variable actually shadows this external variable from this point until it is in the scope. Now if I actually want to access the global variable in this case, then I could do something like this. Maybe I can one approach would be to create a reference variable and call it some xr equals to x. So now at this point xr will be a reference variable referring to the global variable. Then you can use the global variable through the reference. Let me make sure that we don't have issue with this code. This is the compilation linking command and execution. So we didn't have issue, it is displayed. Initially the global variable was displayed 5, and then 3.5 was the local variable, and then global variable accessed through the reference. You can also access the global variable using this syntax. So if you put multiple colon before value x, it will be the global variable that is going to be accessed. So in the terminal, so it is the global variable that is accessed. If you look into the if statement, for example, suppose everything here is in the if statement, I want to make sure that this if statement code or the code in this block of if statement is executed. So in this case also the if you define a variable in local scope, it actually shadows the variable in the global scope or broader scope. For example, if I have another variable here, say int x equals to, let's say, 15, and I want to, yeah, this reference will actually now refer to this 50 variable 15. So through the reference we should be able to access this the local the variable which is local in the main function. This syntax will allow you to access the global variable, this right, and here variable x will actually shadow the both this variable that was defined in the main function and also the variable which is defined in the global scope. So you can see the variable 15 is displayed first. This was the variable that was defined in the main function. It was accessed, it was displayed using cout statement, and local variable we shadowed this x global main function variable and global variable, and we accessed the main function local variable through reference, and we accessed the global variable through this syntax. Now this also applies in the loop, not only in the if statement. If you have this thing in the loop for int I equals to 0, I less than 2, I plus plus, in this case also it is the same thing that happens here. You have this variable x defined in the main function scope, and that variable value will be displayed by this cout statement, and then we have another variable defined within the block scope of the for loop. This is the reference, and this is the variable defined, and then this will actually shadow, this variable will shadow all the other variables, and this reference will give you access to the this variable, and this syntax will give you access to the global variable. Let's see what happens. There could be some issues here as well. So let me copy this and try to analyze it carefully. I'm copying this output into the core here. So in the first loop, this loop the iteration iterates for 2 times, I equals to 0 and I equals to 1, and first it is a 15, this value is displayed, and then local, and then x actually its shadowed is displayed 3.5, and xr actually is reference to this x, so 15 was displayed, and this is the global access to the global variable. Now again 15, 3.5, again 15 and 5. So this is just an iteration of the loop for 2 times, and it will apply not only to the for loop, it will also be true in the case of do and while other loops. I encourage you to try practicing this shadowing in also the switch statement, if else statements, and so on. Now shadowing in classes member functions. Now I will talk about shadowing in classes member functions. For that purpose, for the explanation, let me create a class. So anything that is defined here, int x, this has a class scope. This is accessible from the member functions of the class, from the scope of the member function of the class. And suppose we have a constructor initialize to x and print function. So if I try to access x here, it will be the class scope variable that is going to be accessed. And if I define a variable with the same name, then in that case it is going to be this local variable which will shadow the class scope variable with the local variable if you want to access the class scope variable. For example, if you want to access this variable at this point where this local variable is actually shadowing that variable, in that case you can use make use of the keyword called this. So using this keyword, and I mean this is pointed to the current object, so if you have a pointed to the current object, then you can use this operator to access the members, right? Here you can also have another block scope, something like this, and again you can make use of that reference to access this. For example, if I have then it's possible that you can access at this point this x will be the local variable, is not even local to this print, and x will actually be referenced to this class scope variable. So at this point if I use x, it will be it will actually access this class scope variable. So data access through reference would be like this. And also if we have another function, let me have a code to actually use this print function. My class MC, the value, let's say 25, 35, and MC print. And also I can have a function like this, void let's say foo with parameter x. So in this case also this parameter variable will actually shadow this variable. So if I display x here, and also to access the class scope variable, we need to use this pointer. So let me call that function as well, mc.foo. I need to pass argument here. Let me pass let's say 59. Okay, let's switch to the terminal and see the output of this code. So let me copy this output. So oh, I think I forgot to put x here, therefore it's not displaying data in this place. So it should actually display, let's say, the value that is passed 59 here. So we have this 35 displayed because the value initially it was initialized with 35, so class scope variable actually carried this 35 value here, and we have local variable overriding the shadowing this class scope variable, and here the value 20 was displayed, and we access this through using this pointer. This is the class scope variable, data content by class scope variable, and we have this within this block scope we used a reference to access, but with the same name. So this x actually shadowed this variable, so we are able to access class scope variable data, and here this is the data that is passed when calling this function 59 is displayed here, and again class scope variable or data content by the class member variable is displayed using this syntax. Now shadowing in inheritance. The shadowing in the local scope, in the if statement scope, in loop scope, in the function scope, and in the classes member function do apply in inheritance as well, because it has a base class and drive class, and it has a logic. Here I'm going to be talking another special cases of shadowing, where the drive class member function shadows the base class member function. So let me have a base class first called person. I didn't want to have any data here, just to make it easy to explain. Let me begin with I want to have a function called, let's say, class name. It actually displays the name of the class. This is the base class, and let me create a drive class called student. I want to have the same name in the student class. I mean function with the same name. But it displays the text student. So we have the inheritance with person as a base class and student as a drive class. Now the shadowing here is that if I actually call this class name function from the scope of student, then it is always this function is actually called, right? For example, I could call the class name here, but it would actually lead to runtime error, because this function will be called indefinitely, infinitely. So it will call this function, execute the logic, and again it will call itself. So it's going to be infinite calling. So it's not a good idea to have this function here called. So I want to create another function, maybe call it let's say display, and from within this I call class name. So, or you can have any other functions, you can call this class name from other functions. It's going to be the drive class version of the name that is called, which is in this scope, in the scope of student, it is student class. The student version of this class name function actually shadows the base class function. But if you don't have this student version of a class, then it is going to be the base class function that is actually inherited. This student class inherits the base class function. It actually will call that base class version of the function. So let me create a student object st and call dot display function, or also called st dot class name. So in this case, display should actually call that base class function, and this class name, I mean this invocation, this statement should also call the base class version of the name, because we didn't have the function with the same name in the derived class. Let's see first the output. So a person text is displayed, that means that function is actually called. Now if I have the uncomment this, so that I have the same function with the same name in the derived class. Now in this case, it is a student text display. That means the derived class version is actually shadowing the base class version. And one thing that to notice here is that even if you have another function, let's say function with overloaded function with a different signature, something like this, and I want to actually display this person actually surrounded by the characters that are actually received. So even if I call this, because all these two classes, these functions are inherited by student class, even if I call that this function from here, it will not allow access to this function. Because of the shadowing effect, compiler will try to see this the function with the same signature in the derived class, right? So if I have something like this, so I need to pass a character here. Right, so in this case, if I try to compile this, I will actually get error. So it is not finding the function with matching signature. That means it is actually looking into the derived class only, even if the function was inherited from the base class. So the thing is that if you have a function in the derived class and the function with the same name in the base class, the derived class function will shadow the base class function regardless of the signature of the function. So you cannot even call this function from here as well. Right. So to overcome this shadowing, you can use some techniques. If you want the base class function to be called, then you can give the scope like this, so that compiler knows it has to call the base class version of the function. And also if you want to call base class through the object, then you can give that scope like this. Now it is executed. This was the base class version of the function invoked, and this is also the outcome of the base class version of the function invoked. Now let us try to understand shadowing versus overriding in inheritance. I am using the same code that I got from the previous discussion to explain the overriding versus shadowing. I use this code to explain the shadowing in the inheritance, where the class, this function actually was shadowing both this function and this function from the base class within the scope of the derived class. Now overloading, overriding, sorry. So overriding is a kind of different concept than shadowing. It's not similar, but I'm explaining it because there could be a confusion um, of understanding what is shadowing, what is overriding. Sometimes it looks kind of similar, but it is a different thing. Shadowing actually prevents the derived class logic or derived class object from directly accessing the base class function. It is its effect is prevention, right? But on the other hand, overriding, it actually does not care about preventing. The purpose is not preventing. Its purpose is to enable the dynamic binding or late binding or dynamic dispatch. So we want to actually avoid shadowing. Shadowing is something you want to avoid for good code. Overriding is something you want to actually implement, realize for dynamic dispatch, for dynamic polymorphism. So one thing is you want to avoid, one thing is you don't want to avoid, you want to actually utilize. Okay, so having to explained this much, let me see this overriding and shadowing from this code. We have a base class person and derived class student with a member function class name and display. For overriding, let me remove this thing because we want to have same function in base and derived class. Let me remove the logic here. So we need to overriding actually or dynamic polymorphism applies in the case where you have a base class pointer actually pointing to either base class object or derived class object. We have a person. Let me create a base class object, base pointer, call it BPTR. This is person object and equals to new student, and I can use why it's not coming. Let me first make sure that this because I suspect there could be some issues. I want to make sure that this code doesn't have any problems, so I try to compile it first. Yeah, it is working, I guess. And we have a base class person. I want to create a pointer, base class pointer, pointing to a student object, and let me focus on only this, having this base class pointer pointing to the derived class object, because we actually want to explain the difference between this shadowing and overriding. So shadowing actually happens in the derived class. Now if I use this BPTR to call the derived class object, derived class function, class name, in this case actually we expect in a dynamic polymorphism, we expect that we have a class with the same name in the base class with the in the derived class. So we expect this function to be executed, but that doesn't happen in this case. So let us see it not happening. So this is actually displaying the person. That means the base class version of the function is actually invoked there. So it is actually calling this base class version of the function. The reason is calling is that this is the type of this pointer is person pointer, and actually compiler knows which compiler actually at this point compiler knows that it is the base class function to which this invocation is to be binded with. So compiler binds this invocation to the base class function. It happens in compile time. So this is not the polymorphism realized. Is I mean polymorphism is not realized at this point. And also, and to realize the polymorphism, you need to make this function which you want to call. You want to behave differently. That means the function that is called actually should be based on the object that pointer is pointing to, not based on the pointer type of the pointer. So in this case, you want to if you want to realize that, make that happen, or realize the polymorphism, you need to make this function virtual. So at this point, now compiler will actually determine which function to bind to this function call at the runtime. So this is called dynamic dispatch actually happens in this case. But still at this point, even we say that it is now in this case it is overriding this is a function that actually is created by overriding this function, and it is always a good idea to put this keyword override for avoiding problems. For example, if I have this override and I don't have this virtual keyword, then a compiler will actually complain this. So if I try to run this with that change, I will see a complaint, because compiler will know that that function that is overriding. I mean is to be overridden must be a virtual function. So this will actually I mean force the programmers, coders, to make sure that something to find out that keyword is missing, which is a virtual keyword in this place. Now still we have this overriding. There could be still the shadowing happening. For example, if I call this function here, in this case again it is a shadowing happening. It is not calling the base class version of the function, and also if you want to call the base class version, then you can be explicit in the scope. And also if you have a syntax like this, so the pointer, and if you put this prefix, then at this point the compiler knows it is the base class version of the function that is to be binded. So it binding of this invocation actually happens at compile time. So this is not the dynamic dispatch doesn't take place in this case. Dynamic dispatch takes place in this case. And And another thing is that sometimes you may be tempted to do something like this. Just to enforce this compile type binding for this class name for the student object. This is actually not allowed because this is a base class pointer, so you cannot actually qualify this function invocation with the derived class name. If you want to do this, the proper way of doing it is cast this pointer to the derived class type and then do that. For example, something like this. Let me first make sure that it actually complains. Just I want to make sure show to you that we actually get complain by that statement. So it is complaining. This is not a base of the person. So if you want to actually do static binding to the derived class function, then you can cast this to, let's say, is derived class pointer and call through it, right? This is the correct way of doing it. And then it is actually binding that happens is compile time binding. So it is working, right? So to sum up, shadowing and overriding are different concepts. Shadowing is something that we want to avoid, but overriding is something that we encourage or we want to implement correctly. Thank you for watching this recording on shadowing.